It's my great pleasure to share our experience from Heidelberg using the TomoTherapy system within the next 15 to 20 minutes during the session here. Maybe first thing you'll notice, well, that is a very long title, so I apologize for such a long title, but let me explain a little bit the background of that, why we came up with that idea. Of course, you're all aware of the general topic of this year's Astro meeting, dealing with the marriage of technology and biology, how to bring that together for new approaches for the therapy of our patients, and we try to take up this major theme of personalized oncology, technology, and biology, and show you how you can do that, or how you can really bring that to your patient with a TomoTherapy system. So what we're talking about in personalized oncology is individualized treatment, tailor-made, really precisely fitting to our patients, and not just the standard and average treatment for every patient the same. So that's what personalized oncology is all about, and this is what medical oncology, people are talking about that all the time, and they're looking for targeted approaches, for more individualized approaches, and it's become almost a unique industry now, targeted oncology and new drugs with a specific target in the tumor cells, not really hitting the entire body, but just the tumor cell or a specific target in the tumor, with selective accumulation, less effects on normal tissue, and modifications of a therapy to an individual risk situation. This is what's happening in medical oncology all the time, and of course this is a magical question. Everybody is looking for such a solution that can address all these issues and can be very tailor-made and precise and individualized. And if we ask ourselves, well, what's actually the most perfect drug in this regard, something that can be precisely brought into the tumor, that can be adjusted in dose, where can you put more of that drug or less of that drug in a particular area of the body, where you could avoid other organs, and a drug that we have almost 120 years of experience with that drug. Well, from my point of view, it's the X-ray. Well, 120 years, not quite correct, it's 119 years since this guy in Germany detected the X-ray, since Röntgen found that in Würzburg in Germany at that time. But basically, I think as a profession of radiation oncologists, we can really say that we have a fantastic targeted drug for individualized approaches, for personalized approaches with these characteristics here. And I'd like to show you how you can use this drug with the technology of TomoTherapy for the benefit of our patients. So what I'm going to go through in my talk is give you a little background and show you how we use TomoTherapy, or how I've been using it throughout the last 8 years in Heidelberg, and also, of course, go to the specifics and the details of the new technology of current helical TomoTherapy today, what you can do with it, with the Volo system, with the Edge system, and show you what impact that has on workflow and on the quality of treatments for our patient. First of all, as Calvin already said, it's an 8-year history of TomoTherapy since 2006 now. First high art system at that time, first HD system in 2011, first Edge patient in March last year, and also our second system has been upgraded, and it's really become a big workhorse for the complicated things. And what's currently happening is that we're treating about 100, 110, up to 120 patients on the 2 Tomo machines in Heidelberg, and with the new technology we're able to do that with time slots depending on the complexity of the case. Well, on average you can say 5 patients per hour, and that's full image guided complex helical IMRT cases, and it's almost 4,000 patients in total that we've treated with TomoTherapy so far. A huge spectrum. We don't want to go through details here, just to show you that this is far away from a little niche lesion for just a couple of specific cases and some special cases. So it really has become a working horse for our pelvic IMRT cases, for our head and neck cases, and for all sorts of different things. There's virtually nothing that you cannot treat with Tomo. And it's really taking over the part of the working horse in our department. You can see the numbers per year treated, that's patients per year treated with IMRT in Heidelberg. going all the way back to 97, starting with the first step and shoot patient, and we're almost crossing the 1,000 patients per year with the TomoTherapy now. Maybe next year. This year it's going to be almost 900, thanks to the speed of the new Volo and Edge systems. So, just a few examples to show you what's possible, especially for our complex head and neck patients. We're using TomoTherapy as the preferred choice. We're also using VMAT and also step and shoot for that. But whenever it becomes more complicated, especially in simultaneous integrated boost concepts, we see that the parietal gland sparing and also the dose homogeneity in our targets is by far superior, and also the planning process is just a lot faster than what we see with VMAT or step and shoot planning, and things have really changed. A couple of years ago we asked ourselves, does this patient really need Tomo? Do we need to do all the extra effort for this patient? And now we actually ask it the other way around. Well, why bother with 3D in lots of fields? Do it with Tomo, and we have a very fast planning procedure, and also the application of these plans is very fast. I'll show you more details of the new Edge software a little bit later in this talk. So for the complex head and neck, it's our number one choice. For the complex pelvis, anal canal cancer, pelvic nodal irradiation of the gynecological tumors, of prostate with nodes. Also here, TomoTherapy is clearly our number one choice. And what we've seen is that the amount of small bowel sparing, genital sparing, and bladder sparing also is better than we see in our other IMRT options. And again here, the planning process, the ease of planning, the speed of planning is really fantastic. So you can do these plans really in a couple of minutes. Again, I'll show you a little bit more detail here. But you can say, well, head and neck and pelvis, well, other machines can do that as well. There's a couple of things that TomoTherapy is actually really unique and has unique capabilities, and that's the very complex geometry, superficial lesions like here, skin lesions, a superficial skin lymphoma of the entire face. So things that would give us a very hard time with electron beams, photon beams, and other technologies. You do a plan like that in a couple of minutes, and you can apply it also in a couple of minutes. And it's taking a lot of stress of the whole team, both in planning and at the machine in application. And that is also true for complex re-irradiation. So especially these re-irradiations, I don't know how it's in your institution, but we keep seeing more and more patients for retreatments. These patients live longer, they come back for retreatments, and we start worrying about retreatments and the third and the fourth one and these things. And we do these sort of, like in this example, spinal cord sparing treatments, retreatments, where we really deliver 70 gray right next to the spinal cord, as it's shown in this case, or multiple target treatments in a way that we actually could have never done before. This is an example of multiple metastases of a rare cancer, of a Merkel cell carcinoma. All chemotherapeutic options have already been, used before, and this patient came for a palliative treatment. And within just 9 minutes, you can treat these multiple painful lesions. You've got a plan like that in a couple of minutes, and what that would mean to another accelerator in your system with multiple plans and really multiple treatments, that would be like 30, 40, 50 minutes maybe on another machine, and a 9-minute treatment for complex multi-target cases like that. And we see more of these patients in oligometastatic disease, from colorectal cancer, from breast cancer, from melanoma, and with the TomoTherapy system in palliative or in curative intent. We treat these multiple lesion sites in a very, very fast and efficient way. So just a few examples of the versatility of the system, what you can do with it. First, new, already a couple of months or years old innovation, but that has really dramatically changed the way we use TomoTherapy, is the Volo system. Now, behind the Volo this is an acronym for voxel-less optimizer. It basically means that this is a completely new way of of doing a calculation of your treatment. I'm not going to explain that to you. You don't want to hear that from a physician, so I'm a radiation oncologist. I really don't understand a whole lot of the mathematics in the background. But basically, I think what's essential about it, that this comes from 3D calculations from the computer graphics industry and these things, and were applied to the complexity of those calculations, and things were just accelerated a lot and dramatically compared to the way that we're used to. And these new possibilities and these new algorithms here help us to do all the calculations during an optimization process a lot faster. Again, I don't want to go into details here. You need to ask the computer specialist from Accuray explaining that in detail. But what it essentially means to clinical reality is that it cuts down the way or the time that's necessary to create these IMRT plans that I just showed you, really to a handful of minutes, to a couple of minutes. You see a couple of examples here going from really complex stuff like total marrow irradiation to head and neck cases boost, with very short pre-processing time, especially all the old batch process of beamlet pre-calculation has completely gone. And the entire process of planning and optimizing an IMRT plan has really gone down to a couple of minutes, as shown in this graph. Well, it might not be the perfect plan at the end of 7 minutes, but you will at least have a really very, very good plan. There might be some refinements necessary, but from the clinical routine, I can tell you that after 10 minutes, you have an easy plan ready, and after 15 or 20 minutes, you have a very complex head and neck or multi-target plan ready. And this is really speeding up the whole process a lot. And many of the things that people used to say about TomoTherapy, oh, this is so slow and this takes so much time, these were ended really by these new innovations, especially the pre-processing, the beamlet calculation, all these things. We've seen a remarkable time sparing. And as I told you before, things have changed. We're now doing rather Tomo in many cases than 3D planning because of the ease of the planning process, because of the speed of the system. And this has really dramatically changed our planning routine. So in summary, what the Volo system changed for TomoTherapy planning, what Volo changed here for planning, can very fast and very fine calculation grid do these very complex calculations that could have taken you more than an hour before that. It's really a question of minutes now, and it really permits the planner to quickly explore all different options of IMRT planning here, and gives us a lot more options during the planning process. And that's true in routine, and that really saves us a lot of time in routine, but also in emergency cases, STAT-RT as an emergency treatment right on the table, also for the quality assurance processes, also for the physics processes that are necessary here, a remarkable acceleration and improvement. And as the next point I'd like to address is the edge, the dynamic jaw treatment here, or what was referred to in the past as the running start-stop technology. Something where you could actually say, well, why do you need that? I mean, we have so many fantastic options also already with the conventional, with the regular delivery of helical IMRT. What's so important about Tomo Edge? What's the new thing about Edge? Well, the first thing you've got to say is that this is not really a new idea of Accuray of the last couple of years. This is actually a 20 or 21-year-old idea, at least published by Rock Mackey 21 years ago in this initial paper presenting the concept of helical tomotherapy, where you can see a dynamic jaw at the upper part of these images, dynamically adapting the beam to the edge of the tumor, to the superior and inferior edge of the tumor, and closing in and out and making sure that is in a longitudinal gradient as conformal as possible. So not a very new idea, but it hasn't been in routine and in the machine and usable for a very long time. And this has been changed now. So a very quick review of why this is necessary, what's so special about it. So what you have in the tomotherapy machine, you have the possibility to adjust your slit beam, your fan beam, with 3 different sizes by these jaws. You can choose either 5, 2.5, or 1 centimeter. But once you've chosen that during the planning process, this is constant and you can't change it anymore. So it's not a dynamic component. The actually only dynamic component you have is the multi-leaf collimator. And this has been changed now, so we're going from static jaws to dynamic jaws. And this graph shall illustrate what's happening there actually. So you see the fan beam coming out from the source on the top of that image, going through the multi-leaf collimator, and then producing what's called the dose penumbra above the tumor. So you have the tumor that's going to be moved into that fan beam, and you're going to produce some unnecessary dose above the tumor in this part. And you couldn't avoid that with regular tomotherapy. The dynamic jaws now will give you the possibility to dynamically adjust your fan beam to the superior and inferior edge of that target, and thereby minimize the dose penumbra and minimize the dose to that organ at risk, that little organ at risk right above the tumor here. So a substantial improvement in longitudinal dose conformity for these treatment plans. So much for the theory. I think one thing is important to note is that some of these things that have been published initially on the dynamic techniques are available at the moment and some are not. And what's available at the moment is what was initially referred as the running stop technology. That is what you can get as a Tomo Edge in the new HDA series. Other dynamic components, permanent dynamic jaws and things like that, they are still on the wish list for Santa Claus and not available at the moment. So that's often confused sometimes at the moment. The dynamic possibilities refer to the running stop technology, and they are named Tomo Edge. And what that means is it has a dramatic impact on dose penumbra, on plan quality, and also of the speed of the application. So just a few examples to show you and then to come to an end of my tomotherapy presentation. What is possible now is that we can improve the dose conformity of our radiation plans here in an example of a locally advanced nasopharynx cancer, where the old-fashioned way or the regular way of applying tomotherapy here gives a certain amount of dose penumbra to the optic nerves, to the chiasm. Regular way of increasing to 5 centimeter field width, accelerating such a tumor, such a treatment, you can see produces a lot of dose penumbra above the target, a lot of dose to the brainstem, to the optic nerves. Oh, sorry, you can avoid that now with the Edge system on the lower right side. You can make full advantage of accelerated treatment. That's taking only 3 minutes for such a locally advanced head and neck cancer case without the problem of that penumbra. So we finally can make a lot more use of these 5 centimeter beams now. For these specific cases that the skull base is very important. For large volumes, like there's a whole abdominal irradiation shown here, something that took us quite a while to deliver. Really, you can see these 18 minutes in the old-fashioned 2.5 centimeter way. Again, the pure increase of the field width, it was faster, but it came at the cost of lower quality here. And finally, that was changed with the first Edge treatment, and we were in the proud situation of being the first worldwide of doing that in Heidelberg 1.5 years ago now. And since then, we've treated almost 800 patients with Tomo Edge now, meanwhile on two machines now. Again, the full spectrum of clinical oncology that you can see here with dramatic improvement of quality and also of speed. One example here, since I've said we want to talk about individualized, biologically and technologically individualized treatment here, hippocampal sparing whole brain treatments with simultaneous integrated boost that we're doing within a trial. Fantastic possibilities to quickly do that, to quickly plan that, apply a plan like that really in a couple of minutes, and tailoring this dose to the specific situation of our patients. And again, to show you the difference, old regular way of applying tomotherapy and new dynamic way, head and neck, complex head and neck case, a salivary gland tumor here, going from 5 minutes to 2 to 3 minutes. So our average head and neck complex IMRT case is about 3 minutes here at the moment. And also the prostate cancer treatments are at the order of 2 minutes now, so really coming completely to an area of the single arc IMRTs with very fast throughput at the machines. Also the big things to show you, like in a large volume of an esophageal cancer patient here, big things treated within a couple of minutes, 3.6 minutes for such a huge volume, something that would have taken us 7 or 8 minutes a little while ago. So have seen a lot of benefit for the throughput here, also for SBRT cases, like a little lung lesion here. Within 3 minutes you can treat these patients with SBRT. Again, something that would have taken at least double the time with the conventional technology. And it does have especially high input on the large volume irradiation, a hemithoracic irradiation in this specific case. Really a couple of minutes, 5 minutes for a volume like that, for a complex challenge like that, that is having dramatic impact. Of course, there are some limitations. So it's not the case that we can now just treat every single case with a 5 centimeter field width. Some of the cases, as you see here, very complex skull-based lesions. We sometimes still use the 2.5 or even the 1 centimeter field width for a very delicate modulation within the target, like the optic nerve sparing here. So there are still some cases where we use the smaller field width, but most of the cases really can now be treated with the 5 centimeter. And of course, another limitation, one thing is the modulation within a target. Another thing is the 5 centimeter within oblique targets like the sacral body here, or the skull base, or the cervical spine. Sometimes here a smaller field width of 2.5 or 1 centimeter gives you better longitudinal dose homogeneity. So I'd like to conclude with the Tomo Edge system. We do have improved superior-inferior gradients. We can finally now make use of the 5 centimeter field width in a lot more cases, not just really as an exception for big targets, but we use it now in 80% of our cases. It does not come along in most of these cases, in these 80 cases, at the cost of worse dose conformity or worse dose distribution. So it does give you fantastic organ risk sparing like we know it from TomoTherapy. So it's better and faster at the same time, and it does reduce integral dose. And with the Volo, you've got the possibility to really plan this in a very fast fashion. And so this throughput of 50 patients in 12 hours, you can plan all this fast, and you can do all the quality assurance for that in a fast way. And you have easier ways and faster ways for adaptive strategies, for replanning and these things. So it does make adaptive approaches a lot more feasible. It is the key technology in helping a lot for adaptive approaches. And in general, what you can say about TomoTherapy, well, for us, having 6 different linear accelerators in our system, it is the most versatile system. There's virtually nothing we cannot treat with Tomo. Easy things, complicated things, large volumes and multi-targets. The examples I tried to show you here, it's really the most versatile things for all these new approaches that Astro is addressing this year, for new individualized approaches, new biological approaches, being simultaneous integrated boost, conformal avoidance of special structures, hypofractionated or radiosurgical approaches. This system gives you the possibility to address all these issues and bring all these new advantages to your patient. I'd like to thank you very much for your attention.